velocity in one dimension as what? What was our definition of average velocity in one dimension?
delta x على delta t.
ممتاز. And if you want to expand that to 3 dimensions, what happens to it?
دلتا R على دلتا T.
ممتاز. Delta R على delta T. Now I can expand that. بما أنه R is a vector, I can expand that. Delta X in the I direction, delta Y in the J direction, delta Z in the K direction. And when I divide that by delta T, I end up with delta X over delta T, which I can write as Vx in the I direction, plus Vy in the J direction, plus Vz in the K direction. So we have 3 different velocities, one in every direction. Okay. Now this is very important. This is not only a physics thing. This is actually comes from mathematics and the properties of coordinate systems. The x, y, z, or the I, j, k axes are upset with each other. They don't speak to each other. Okay. And this is a fact that we are going to use later on in our course. Okay, actually as soon as the end of today's lecture. Okay, this is a fact that we're going to use to our advantage to make complicated problems simpler. Okay, so keep this in mind. Now, is everyone happy with this? Okay.
Yes.
I have a question. What is delta R?
The displacement
Change in position.
vector.
Final
Displacement vector.
Okay, we have a few answers. Pretty much all of them are correct. Different names for the same thing. It's indeed the displacement vector. It is indeed the final position minus the initial position. And it is indeed, okay, the change in position. All these 3 are correct. But bear that in mind, okay, when we do the upcoming PI question, because it makes a big difference. Ready? Let's start with our first PIQ for the day. We're going to be doing quite a few today. It's quite an interactive lecture. I'm hoping it will also be, to a degree, a fun lecture. Okay, so let's give you about 2.5 minutes for the first question. An eagle flies 300 meters west in 20 seconds and then 400 meters south in 5 seconds. What is the average velocity for the eagle? Okay. Let's see. We have a rather interesting spread of results. We have almost a tie between option A and option C, which I must admit is something that I expected to happen. Now, pretty much everyone who chose option C, I am afraid to say, did not pay attention. What did we say was the definition of velocity? Displacement over time. Now, pretty much everyone who chose option C did this. Starting point, 300 meters, 20 seconds. 400 meters, 5 seconds. Ending point, 300 plus 400 تقسيم 25 seconds يساوي 28 meters per second, which I'm afraid is incorrect because 300 plus 400 is your total distance traveled, not your displacement. What is our displacement here? Our displacement is final position minus initial position, which we can do it in two ways. We can either do it using Pythagoras theorem, or we can do it using vector analysis. Okay, now I am going to be lazy and I am going to do it using Pythagoras. So 300 squared plus 400 squared, all square rooted, divided by 25 seconds, 25 over 5 equals 500 over 25 equals 20 meters per second. So the correct answer is indeed A. So people who did C did the correct calculation, the correct steps, but the incorrect numbers. They looked at distance instead of velocity. وهو خطأ قاتل. So be very careful. When do you use speed? When do you use velocity? Okay. All right. What did we define instantaneous velocity to be?
Doctor,
أيوة.
if the last question in one dimension, see it's correct.
If it is in one dimension,
Yes.
if it's in one dimension, you would end up with, and you're assuming 300 وبعدين 400 in this way, then
Yes.
C and A would be the same thing. They will both be 20 meters per second because your total displacement would be 700. But if, like the example we did in chapter 2, the eagle starts going this way and then starts coming back to this point, then C would again be wrong. Because your displacement is going to be less than your distance.
Okay.
Yeah? Okay. Instantaneous velocity. We defined it as the velocity of a particle at a single point in time. We also defined it as the limit of average velocity as the time interval shrinks to 0. And we defined that to be the tangent or the slope of a position. Do you remember this?
Yes.
Okay, now there's something very important here. When I say this is position A, this is position B, And this is my path or distance or displacement. And when I say this is my velocity, is there a difference between these two arrows في المعنى؟ Any idea? When I draw an arrow between two positions, okay, what does this mean?
Displacement?
Displacement, yes. But what does the arrow mean? The arrow means we are going from part A, from R1 to R2 along that path, صح؟ الخط يوضح الطريق. الخط مستمر. The line actually shows the actual path, correct?
Yes.
Okay, but when we do it for velocity, like here, the orange line, this is the velocity. What does this orange line show? What does this orange arrow show? Does it show the path? Does this arrow actually extend in space?
No.
No.
No. It only shows us the direction and the magnitude. So when I have an arrow, for displacement or for distance that goes from one place to another, that arrow actually means هذا الطريق. But in velocity, I don't mean this whole thing is velocity. I'm saying, okay, my velocity is this magnitude in that direction. In unit vector form, okay, my velocity is d by dt, the derivative of my position vector, x plus y plus z. صحيح? I will expand it. I will have dx, dy, dz all over dt. And I can rewrite that to be vx, vy, and vz. And we are going to be using this fact that we can look at the velocity in each axis independently from the other axes. We're going to be using this fact extensively in a bit when we look at projectiles. Okay, it makes solving problems much, much easier. Okay. Now this is what I was telling you. The velocity vector does not extend from one point to another. It only shows direction and magnitude. So while on the same drawing, you might have two vectors, two arrows, one showing displacement and one showing velocity, the one in displacement actually does extend from one point to another. It shows you this is the starting point, this is the ending point. The velocity one does not do that. It simply shows you the magnitude and the direction. Do you have any questions on what we have said so far?
No.
No? Okay. Are we all happy with what the velocity, what velocity is, what the definition of velocity is, and how do we calculate it?
Doctor, can you repeat
Which part?
the last part?
If we have two things in the same drawing?
Yes.
So in this drawing, we have the xy axis. We have two vectors. We have the brown vector, which is labeled path, and this is literally a vector extending from point A to point B. You can think of it as a rope that is connecting the two parts. Okay, this is the actual road the particle takes. But the purple vector, which is labeled tangent and which is labeled as velocity, only shows me the direction and the magnitude at that instant. It does not mean that velocity goes from here to here. This is not what it's saying. It's not saying that velocity goes from this point to this point. It simply says velocity is in this direction. Yeah?
In the right second, right?
In that second, yes, at that moment.
Doctor,
Yeah?
can we solve a question that's about this, like this graph, like this?
Yes, why not? Why not? You know what? Let us solve more than one question. Let's do this first. So I'll start with PIQ2. I'll click on, where's next question? Next question. Okay. It's not too complicated of a question, so I'll give you about 2 minutes for it. And go. Let's do this one individually. The x and y coordinates of a particle as a function of time are x of t is b plus ct and y of t are d minus et. Which of these arrows show the velocity of the particle? Now we don't have a drawing, we have an equation. So what do we do to it to show us the velocity?
Derive it.
Sorry?
Derive it.
Possibly, yes. If you believe that is so, then do it and put your answer, choose which one is the correct one in the PIQ. Okay. Let us take a look. Okay, let's see. Very, very interesting. We have a large number of people who chose option D. Second large number is option C. And then we have almost equal number of people, options A and B. Okay. We have x of t equals b plus ct, and y of t equals d minus et. If I want to find velocity, how do I do that?
Derivative.
Okay, so x prime equals vx.
C.
What is it going to be? Just c.
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 Okay. And what about y prime or vy?
E.
Minus E. Minus E.
Minus e, because we have a minus there. So now in the x-axis, we have vx equals positive c and vy equals negative e. That tells me I have a positive thing in the x-axis and a negative thing in the y-axis. صحيح?
Yes.
So if I have something that is in this direction, x-axis and y-axis, what is its resultant going to be?
D.
It's going to be in this direction, صح?
Yes.
Now, where exactly in this direction is subject to interpretation, depending which one is bigger on the magnitude of x and y. If x is 10 and y is 1, then my vector is going to be something like this. If x is 1 and y is 10, my vector is going to be something like this. And if they are equal, it's going to be on an angle of 45 degrees. But it has to be between the x and the y, صحيح?
Yes.
Yes.
So my only option here
Yes.
is D. Okay. A and B are not possible because A has positive x but positive y, so that's not possible. B has negative x, so already wrong. C also has negative x, so wrong. The only possible option is option D.
Doctor, please repeat.
So we did the derivative, صح? And we found that our x component of velocity is positive and our y component of velocity is negative. This means my velocity vx, vy, which means my velocity needs to be somewhere in this direction, بينهم. So the only option for that is option D.
Okay, thank you, Doctor.
Okay? All right. Now, we move from velocity to acceleration. Is it the same idea or is it a different idea? It's the same idea, just like in one dimension. Just like here, we're going to extend it to 3 dimension. In x-axis and only 1 dimension, our acceleration was v2 minus v1. Like in v2, v1 were just scalars, just numbers. Here again we have v2 minus v1, but now v2 and v1 are actually what? Are actually vectors. So again we have delta v over delta t. And again acceleration is equal to dv over dt. الحين وين تجي الفرقية؟ Say my v2 is 2i plus 3j minus 6k meters per second. And my v1 is equal to I plus 2j plus 3k meters per second. What is my acceleration going to be? My average acceleration. Anyone?
V2 minus V1.
V2 minus V1. So I will have 2 minus 1 in the I direction plus 3 minus 2 in the j direction plus minus 6 minus 3 in the k direction divided by, let's say delta t is 2 seconds to make it simple. No, you know what? Let's keep it 1 second to keep it simple. Divided by 1 second. What will I end up with? I will end up with I plus j minus 9k meters per second squared. This is my acceleration in the x-axis. This is my acceleration in the y-axis. And this is my acceleration in the z-axis. بالضبط كيف ما في الفيلوسيتي كان عندنا vx vy vz، في الاكسلريشن عندنا ax ay az. Simple enough.
Do you just keep it like that, or do we find the
No, that's
function?
it. This is my acceleration. It's a vector. Now, if I want, I can do another thing. I can do ax squared plus ay squared plus az squared, and I take the square root, and I will find the magnitude of acceleration. Then I need to do tan inverse of ay over ax to get angle theta. Then I will need to do tan inverse of angle az over ax or az over ay, depending on my angle on my coordinate system, and find angle alpha. وأقول, okay, I have acceleration with magnitude كذا with this angle and that angle. But the result is still the same. It's still a vector, صح?
Yes.
Yes.
Okay. Any questions on this? Let's see if we have understood this. Now, we have enough time to do it before and after. Yes. So let's do this question. Okay, and I will give you about 2 minutes again for this. And let's see how we do. I have marked the quadrants 1, 2, 3, and 4 in case you have forgotten what a quadrant is from trigonometry. By the way, Arthur and Noor and anyone else, I don't have access to the chat screen while I am on full screen presenting something. So if there is something, just open your mic and say it, please, so I can hear you, okay? All right, so let's see. We have a very interesting spread of result, and I am not showing you what these results are on purpose, okay? So we have an equal number of students, give or take, who have chosen the correct answer. So about 48% of students have chosen the correct answer, and about 46% of students have chosen an incorrect answer. Okay, which are both very, very close. Now, this is a very, very interesting approach, okay, and which is something which I want to show you, which I want to try with you. I'm not actually going to tell you which half have chosen the correct answer and which have chosen the incorrect answer. Okay.
Doctor,
What? Yeah.
I think you stop present the
Yes,
screen.
I stopped presenting on purpose because I don't want you to see the results that I am viewing at.
Okay.
Okay. So half the students have answered correctly and the other half have answered incorrectly. And I want to try a little experiment, which has proven very, very successful at universities like Harvard and MIT. Okay. What I'm going to do now is I am going to repost the same question, but I'm going to break you down into rooms, into breakout rooms, where you can discuss amongst yourselves, your colleagues, okay, your answers. Now, you don't know whether your answer was correct or incorrect. Okay, so you are going to try to convince your colleagues that your answer is the right one, and you're going to teach each other, because teaching is the best way to understand. Okay.
But we can't see the question anymore.
The question will show up again in a second.
Okay.
Okay. So I am going to give you about 4 minutes this time because you need enough time to discuss. Okay. And here we go. Okay. And let's try. Let's see what we end up with. Ready? The question will now go out again. And let's see if we can get a better proportion of correct to incorrect. And breakout rooms start.
دكتور
ايوه
الأسئلة ما تظهر عندي.
في البي اي كيو.
ايوه.
try to refresh.
عملت ريفرش ماشي.
ايش يطلع عندك؟ ايش يبين؟
يطلع يكتب لي you have no tries left for the question.
You have no tries left for the question. انت
Yes.
في PIQs number 7.
والله ما أعرف حتى يعني ما يوصلني الرابط كل مرة.
لا انت ايش فاتح في مودر الحين؟ على ايش ضاغط؟
BIQ 7.
ايش كذا؟ This is weird. انت سالم معي صح؟
ايوه نعم.
سالم الخنبشي section 30. هل أنت على التليفون ولا على لابتوب؟
على التلفون.
That might be the reason, but I'm not sure.
حتى ما يوصلني رابط إني أدخل عند مجموعة يعني.
أنت تتكلم على البي اي كيو ولا على المجموعة؟
الاثنين.
البي اي كيو ما أعرف إيش الإشكالية فيه.
حتى الكويز الماضي واللي قبله نفس المشكلة، يظهر سؤال سؤالين فقط وبعدين تصير.
Then let me try to do something. Let me see if I can do something to fix it. بالنسبة للبريك اوت روم ما يجي لك الرابط، حاول انك تعمل ابديت للابلكيشن مال جوجل ميت في التليفون الى الليتست فيرجن. Okay, pretty much everyone is back. I'm going to end the question now and see how the responses are. Okay, I'll share the screen again. Not sure what am I presenting, so I'm going to redo the whole thing. Entire screen. Okay. So, the first time round, show responses. The first time round, we had about a 50-50% split between the first quadrant and the fourth quadrant. The second time round, about 75% of students answered first quadrant, and 25% of students answered fourth quadrant. So the balance shifted. The correct answer is indeed the first quadrant, and I'm going to show you why. So the figure shows you the path, and you want to know the velocity is in which quadrant. If I have a path, how do I find out what is the velocity on a graph? What do I do?
Divide it.
Okay, I derive it, but now I don't have an equation to derive. I just have a figure. So what do I do?
We have to put point.
Okay, tangent. So it is traveling clockwise. So it is going like this, مع عقارب الساعة, which means the velocity here will be like this. The velocity here will be like this. The velocity here will be like this. And the velocity here will be like this. صح? Do we agree so far?
Yes.
Yes.
Okay. My velocity is equal to 2I minus 2J, according to the question. So I have 2I and I have minus 2J. So in which direction will my velocity vector be? If this is my I and this is my J component.
Fourth.
It should be like this, صحيح?
First one.
So the correct answer is the first quadrant. It cannot be the fourth quadrant because the fourth quadrant velocity is like this, which means its J component is negative, but also its I component is negative. But our I component here is positive. So it cannot be the fourth quadrant. Yeah?
Doctor,
Aywa?
there is another way,
Yeah.
which
tell
I
me.
know. We can put point in each coordinator in the circle.
Mm-hmm.
Then we can do the x-axis and the y-axis. I think it will be clear. I have the drawing now.
Is it on the screen? Can you share your screen?
I draw it in paper, not in.
Okay, so in that case, let me try something and you can tell me if this is what you did or not. So what you mean is you do something like this, and then, so this is in this direction. You will have something like this.
Yes.
This is what you mean?
Yes, I draw in each coordinator. And
Yes,
each,
that is the same thing. That is the same thing. But you need to be careful in your brain that what you are actually drawing the components of is not the path, but the tangent of the path. So when you're doing these arrows to this and to this, you're not doing it for this line. You're doing it for the tangent of this line. Okay. So for example, say if you have an XY axis and you have a drawing that looks like this. At this point, how will you write? How will you do the X and Y axis? How will you draw it? At this blue point.
it is the same first one.
X is 0.
So like this. كذاك. But how do you know this is down or up or left or right? It doesn't really work. What you need to do is you need to draw a tangent, which is your slope, and that would actually be simply a straight line, right? So your y component here is 0, and your x component here is positive. So you need to be very careful to pay attention to the fact that the arrows you're drawing is for the tangent of the line, not the line itself. Okay?
Okay.
to get the components of acceleration, as you said, we differentiate the components of velocity. We had components of position vector. We differentiated them, we got components of velocity. We differentiate the components of velocity, we get the components of acceleration. صحيح?
Yes.
Okay. Let's see if we can do this one correctly. So I will release PIQ 5 now. It will release in 3, 2, 1, and go. And I will give you about 2 minutes to do it. So this is the same one we did before, B plus CT and D minus ET, but this time we're looking for acceleration, we're not looking for velocity. Excellent. With the exception of 10, 15 people, pretty much everyone got the correct result. It is indeed 0. The result is indeed 0. We had x of t, b plus ct, x prime or v was simply c, which means x double prime or a will simply be 0. And the same thing with y, d minus et, y prime was simply minus e, and y double prime would be 0. So my correct answer would be e, it's 0. Okay. We move on now to the idea of who here has not played this game? Have we all played this game at one point or another?
Yes.
Angry Birds?
Yes.
Now you would remember when we played this game, okay, we needed to choose the angle. We needed to choose two things: the angle of launch and how much we pulled back on the catapult, right? If the angle was too low, it would go meow. And if the angle was too high, it would go ee. There's no point. And if the angle was just right, you needed to hit it at a specific angle to make the whole thing just drop dead, right? Now today, what we're going to do is we are going to analyze this motion and try to figure out what is the physics behind this game. Okay, this game has very, very simple physics behind it. There's nothing complicated, and we're actually going to be learning it today in projectile motion. You might have done a bit of this before or all of it before in Arabic. باسم المقذوفات. Now, we have four kinematic or three main kinematic equations which describe an object's motion, right? V equals U plus AT, V squared equals U squared plus 2AS, S equals UT plus half AT squared, and V equals initial velocity plus final velocity divided by 2 for average velocity. You remember these four equations?
Yes.
Okay. If there is no air resistance, then all objects, regardless of weight and size, will fall at the same acceleration, which is the acceleration of gravity, which is 9.81 meters per second squared. And we all remember that. Do we all remember the video we watched together?
Yes.
Yes.
Okay.
Yes.
Excellent.
Yes.
Excellent. Now, what is the direction of G, of gravity? G always acts vertically towards Earth, and vertically is a very, very important word here. So we're going to utilize our friendly neighborhood Spider-Man to explain this to us. When Spider-Man is standing up, what is the direction of the gravity's pull?
Below him.
Down.
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 So, like this?
Yes.
Yes.
Okay. What about when Spider-Man is at an angle?
Down.
So, down?
No.
Vertically.
No.
Straight down.
No.
No. It's still down vertically, right?
Yes.
What if Spider-Man is
Yes.
upside down?
Same thing.
Down vertical.
Still down. If he let go of that thing, بيطيح وبيندبغ على راسه. What about when he's at this angle?
Same.
Same.
Okay. عنيدين into. What about this?
Still
Still down.
Also.
Still down. Okay. Now this is a key point. This might look like a stupid slide, but this is a very key point because this making the mistake of using this line that I made here is something very commonly done by both students and instructors when they're doing problems very, very quickly. Okay, because we are used to gravity being in the direction of the object. So if something like Spider-Man at an angle, our brain usually goes, okay, يلا بسرعة بسرعة. This is the direction. وبعدين تصير مصيبة سوداء because that is not correct. Okay. Now, here's a ball, okay, that is falling down. That's okay. Its initial velocity is 0, so it is released from rest. And the law that we use to calculate its velocity is V equals U plus AT. صحيح? Yes?
Yes.
Where AY is equal to gravity. Okay. Now, I have wrote it here. Do not memorize this as a rule, okay? Because as we have shown before, G can be positive or negative, depending on how we have chosen it. But fine. What about when my object is going to the right? Initially, it is at AX equals 0, and it moves in this direction. Okay. Initially, it is at Vx, some velocity, but it has no acceleration because acceleration of gravity is only downwards. صح? In the x-axis, there is no gravity.
True.
So what's its final velocity going to be?
The same as the beginning?
The same as the beginning, صح? Our rule is v equals u plus at. وبما أنه my acceleration is 0, I will end up with v equals u. تمام؟ Now what happens when I put these two things together? What do you think will happen?
Change in the velocity.
Okay, to what effect? What is the direction of my velocity going to be?
Between them. Like a key.
Vertically toward?
Z direction.
So this
Curve. A curve.
1, 2, or 3.
3.
3.
3.
Okay.
Three directions.
But there is something that is happening. Okay. There is something very key that is happening. We said acceleration in the x-axis is 0, صحيح? So my Vx is the same at every single minute. There's nothing slowing it down or speeding it up, صحيح?
Yes.
But what is my acceleration in the y-axis?
9.81.
So if at time 0, my velocity in the y-axis is 0, what is it at time equals 1?
9.8.
9.8, صح?
Yes.
So my y-axis becomes bigger and bigger.
Yes.
So if I'm trying to look at the resultant, my resultant will keep going more down and down because my angle of theta equals tan inverse y over x is going to become bigger and bigger.
True.
صحيح?
Right.
Okay. Which means this thing is going to end up, if I just trace this line, the red line, what does it look like?
A curve.
It looks like a curve. And this is exactly how Angry Birds work. And this is exactly how when you kick a football, it works. This is exactly when your mom is angry at you and throws a tissue box at you. This is exactly how the physics works. Or, you know, in the classic in the classic Omani sense, this is the physics you need to work with if you are ever going to get out of this hitting you. Okay. Now, ما حد يسوي نفسه انه ما عنده خبر. كلنا نعرف انه هذا له طاقة صاروخية على تتبع الاشخاص. It's even better than American made missiles. الصاروخ الامريكي لما يطلع من الطائرة ممكن يخطئ الهدف. But this thing never misses. It doesn't matter. You zig, you zag, you go down, you go up. That thing is gonna hit you. It's gonna hit you. And there's unlimited ammo of it. Okay. So this is the physics of how each one of us was at some point hit by this thing. Okay. and then now here's the thing, okay? At this point, we're looking at balls, okay? And we're looking at small enough objects like, Zanuba, which is fairly can be modeled as a ball in one way or another, okay? Somewhere around chapter 10 or chapter 11, we are going to start discussing the physics of وش يسموها يا أخي؟ نسيت اسمها. المخممة للقش، إيش اسمها؟ حد يذكرني يا جماعة.
مقاشبة.
أيوة.
جمعة.
أيوة. كل واحد هنا له اسم، لكن كلنا نعرف عن إيش يتكلم. هذه المجمعة هذه هي ستيب 2. إذا الزنوبة ما لحقت تجي وراك هذيك. إنزين.
قوة دورانية.
إنزين. At chapter 10 or chapter 11 we are going to discuss if بمعجزة من المعجزات. إنزين. You managed to get out of this. كيف that thing is going to come at you, and why does it rotate once it is aimed at you. اوكي عشان ما تقولوا انه هذا الكورس كله ثيوري وما في له فائده عمليه وكله ملل. احنا نعلمكم مهارات مهمه جدا في الحياه العمليه. انزين. طيب انزين. Now, I have actually forgotten to put a lot of these into the PIQ system. So okay, let's discuss this PIQ verbally. Okay. A package is dropped from an airplane flying east. What just happened? Sorry. A package is dropped from an airplane flying east at a constant speed, v plane. What are the components of the initial velocity of the package, v naught x and v naught y, if we ignore air friction? So again, you're going to lay witness to my amazing drawing abilities. Okay, so this is an airplane. Now, this airplane is moving at a constant velocity v plane. Okay, in the x-axis, it's not going up, it's not coming down. Okay, now what are the components of the initial velocity if I drop something out of the plane? What is v naught x and what is v naught y? عدوها عاد شو اسمه
Zeros.
المهارات الرسمية يعني انتوا you have an idea now أنا كيف كانت علاماتي في مادة الرسم فعدوها. إنزين. So what do you think? What would the initial velocity in the y-axis be, and what would the initial velocity for the x-axis be?
Zeros
It
both.
will be the same for the plane.
Okay, so the x-axis will be the same for the plane. What about v naught y?
Gravity.
Go vertically down.
0.
0.
0. Okay. Does anyone disagree with this? Does anyone think this is not correct? It should be something different? So what your colleagues have now described is option C, where v naught x is v plane and v naught y is equal to 0, because package is dropped from a plane moving horizontally. And we are ignoring air resistance. So they have said that at this very moment, when we leave the airplane, we are going to have this VP, and this is going to be 0. Does anyone disagree with this?
No.
No?
No.
What about the gravity?
Yes, Doctor, the gravity.
Okay. So what does the gravity do?
It will increase
After 1 second.
vertical velocity
It
over
will
the
increase the vertical velocity.
The gravity is pulling a thing downwards, صح?
Yeah.
So it will increase the velocity. So whatever my initial velocity is, v naught y, in the y-axis, I am going to have this, v naught y plus minus gt. صحيح? So the gravity is going to increase that velocity on a constant basis. But the question is, what is the initial velocity assassin? Is it negative? Is it positive? Is it 0? Is it a specific number? Do we not know? Do we need more information?
No, it's 0.
0.
Okay. Let's stick with 0. After 10 seconds, okay, what is Vy and what is Vx?
Vx is still the same, and Vy is 10 times 9.8, so 98.
Okay.
Negative 98.
Okay. Why?
Because gravity is 9.8 in the negative direction, or
Okay.
positive, depends on.
And why does it not affect it in the x direction?
Because the gravity is only vertical.
Excellent. That's an excellent answer. Okay, so we will stop today's lecture at this point. And in